We'll do a Tresca yield criteria problem. The following state of stress is from a plane stress condition. Of course, that would mean that we've got zero stress on the face that we're looking at. And we're asked to solve for the normal stress in the x direction such that a factor of safety of 2 is used with Tresca. And we are also told the yield criteria for the material is equal to 50 megapascals. I'll solve this problem using Moore's circle. So rewriting the stress block with the XY coordinate system on. I've just decided to put those on just for bookkeeping purposes. So on the X face, sigma XX in the normal direction. Y normal is -20, compression shows. On the X face, we've got shear stress that would cause the element to rotate counterclockwise, which on Moore's circle sign convention would be -5 and +5 for shear stress Y. So again, remembering that the X face is in tension, we'll go ahead and plot these 2 points. I'm going to label right next to them what their coordinates are. So the X point is at sigma XX -5, the Y point -20 and 5. So though it's a little tricky, but we can calculate the center of the circle, and that center would be at the average normal stress. So it's going to be -20 plus sigma XX divided by 2. So I'll rewrite that as sigma XX over 2 minus 10. So we need the radius to move forward. So I'm going to use that triangle right there with a height of 5. It would have a length. Let's actually go over to this side. So I'll use that R5. And it would have a length of sigma XX minus the center. That would be the total length of that side. So using Pythagorean theorem, r squared would equal 5 squared plus sigma XX. Right, that's sigma XX all the way to the center. That distance, right, is going to be sigma XX minus center. So squared, go ahead and plug in what we know for the center. So that'll go right there. Catching your signage, we end up with 5 squared plus the quantity sigma XX over 2 plus 10 squared. So keeping in mind that sigma XX has to be in tension, we are guaranteed from this circle that this side over here would be sigma 1. The Z point sitting right there at 0 stress is going to be sigma 2, and sigma 3 is going to be sitting over at the center minus R. So let's just go ahead and take inventory of that moving forward. So those are the values that we're going to use for Tresca. So we'll work this equation a little bit. We know that we wanted to use a factor of safety of 2. So I'm going to shuffle this around. Sigma 1 minus sigma 3 is going to equal sigma yield divided by 2. We know that sigma 1 minus sigma 3 is equal to 2R. Go ahead and divide this 2 through. So that would be over 4. I'm going to take that and square both sides. That gives R squared is equal to sigma yield squared over 16. And so we're going to meet that equation for R squared. We're going to meet up with this equation for R squared. And it should become apparent that left over, the only thing we're going to have is sigma XX to solve for. So let's just write the equation for R squared above. That's going to be equal to 1/16 sigma yield squared. So the only thing left is math, and we just need to isolate sigma XX and plug in the value for sigma yield. And this would be the math to finish the problem up. Kind of see how the manipulation goes. 5 goes to the other side. And end up taking a square root And then with just a few more lines, we end up with an answer for sigma xx of 2.91 megapascals.